Hi everyone. Before you listen to me about puzzle number 2, I really would like you to try it on your own and see what you can do. And when you feel like you have a sense of direction after listening to some hints, pause the video and really try to do it independently on your own when you feel like you're like, oh, okay, I understand what's going on. So here you are given clues in probably a different form than you've seen in the past. Remember, we're looking at a puzzle, so we don't have to start in certain places. But you're given this clue that when x is equal to 7, the y value is equal to -3. The reason that I know that is this is function notation, h of 7. h, when x is 7, is equal to -3. The y value is -3. So that's one data point. And then if I look around on the page, I'm trying to say, that's not enough information. I can't find my slope that way. So I need another data point. And if you go back and look at our equation box, you're given that you have a +4 at the end of y equals mx plus c. And we remember that this is the cheating, that's the y-intercept. So when x is equal to 0, y must be equal to 4. Now I have two data points to use. I have the point 7, -3, and the point 0, 4. So y minus y, -3 minus 4, the rise, is equal to -7. And then my run, x minus x, 7 minus 0 is equal to 7. So my slope must be -1. And I can substitute that now into my equation, and I now have my equation. I think I'll do my table next. I mean, I guess I could do my graph because I know that our y-intercept is 0, 4. But that's kind of all, and I know it's going down. That's kind of all I know right now. So I'm going to get some data points on my table. I could go into Desmos, but this is a good one to practice some arithmetic on. So if we substitute in my easiest data point, always start with your easiest, of 0. -1 times 0 is 0 plus 4. Oh yeah, that's the y-intercept. X equals 1. -1 times +1 is -1. -1 plus 4 is +3. And I can keep substituting those in. For instance, let's jump down here. -1 times 10 is -10. -10 plus 4 is -6. Now, work smarter, not harder. This is a constant rate of change. So every step, if it's going up by 1, these should be going down by 1 because your slope is -1. So you could also cheat that way. 6, 5, 4, 3, 2, oh, and then this one jumps to 7. So you have to be a little careful that way. We could now do our graph by plotting these points. So you can see I've made little dots, and those represent my data points from the table. And I got my x-intercept over here by substituting 0 in for y and setting it equal to -1x plus 4. Subtract 4 on both sides and divide by -1, and I get that my x-intercept must be the 0.40. And now I really can finish labeling that graph. My slope was -1, therefore my rate of change, f prime of x, is -1. My relating lines, a parallel line would have the same slope, perpendicular line would have the flipped fraction and made positive, so that would just be +1. And now we have some algebra to do. A quadratic function, q of x, is a x squared plus 4. Algebraically solve when is the quadratic equal to your linear, which is up here, h of x. So we're going to set them equal to each other. And I'm just going to cheat a second here and get them on Desmos. So my left-hand side is -x plus 4. And my right-hand side is a quadratic, x squared plus 4. And so I know that I'll have two solutions. One is x equals 0, and the other one is x equals -1. And I could jot that little graph here and label my solutions just so I know what I'm working towards. So I did the verification first. Since it's quadratic, we want to get, and we have an x term here and an x term here, so we can't do PEMDAS backwards. We're going to move all the x's, or we're going to set this whole equation equal to 0. I like to keep the quadratic term positive, so I'm going to move this to the right-hand side and this to the right-hand side. X squared plus x, and then subtract 4, and those cancel, equals 0. And then these have a common term that I'm going to factor out. They both have an x. So I factor out an x, and I'm left with x plus 1. So therefore, either this equals 0, or this part equals 0, in which case x would be -1. -1 plus 1 is 0. And that matches my graphical solution. So I am done with my quadratic algebra. Determine if the point x equals 8, y equals negative 5 is on the line. So substitute, go back to your pattern, which is up here, and I'm going to substitute y in negative 5 equals negative x plus 4. The left-hand side would say negative 5. Negative 8 plus 4 is negative 4. So those two things are not equal. So this must not be on the line. And I can confirm that on here. 8 comma negative 5. Oops. Is way down here, and it's a little off that line because the line has the point 8 comma negative 4. So it is not on the line. Lastly, find the equation. So start with your Aurelian block. Perpendicular. So your slope would be a positive 1. And the data point would be y equals negative 3, x equals 7. So y minus your y data point would become y plus 3. 1x, and then this is negative 7. So it would become, if you got y by itself, y equals x minus 10. But you could also stop there. That would be a valid form as well. And we can verify that this is perpendicular by graphing it on Desmos. And it does look like it indeed creates a right angle. And goes through the point, does it go through the point 7, negative 3? Let's double check. Convert to table. 7, yep, x equals 7, y equals negative 3, so that works. And we are done with puzzle number 2.